Hey there, Year 11s. We're now going to look at example 10, rewrite each of the following using what they call function notation. So in this case here, you have to know that a function notation, it doesn't have to be F, it could have been G, but the first letter tells you what kind of function you're referring to. So it could be F, G, H, I, J, whatever letter you want to assign it. But then when you do colon, essentially you say, F, this represents, and then X here means the domain. Okay? And then the arrow actually means maps. Maps onto. So it tells you which X values you can have, and it maps onto. Now this is by definition called a codomain. And essentially it's saying that from where do you draw this onto what map? What kind of map do you have? And the best way I normally like to describe it is, okay, X maps onto Y. I think of this as your ice cream flavors. Okay, where are you taking your ice cream flavors from? Well, the ice cream flavors come from all the possible ice creams you can have. Okay, so you can have, say, chocolate, you can have strawberry, you can have, I don't know, banana, vanilla, and the list goes on, right? There's infinite amount. Then the ice creams here is what you want to choose. So you might just want to choose the three standard choc, vanilla, and strawberry. Oh my god, I'm not really in my spelling mode today. Vanilla and strawberry. So you can see this is what a domain is. You're selecting, you're restricting what you want. You may only have said chocolate and vanilla as an example. So that means when you sketch on this x-axis, right, you've chosen the ice cream flavors you want, and you only wanted choc and vanilla. Out of all the possible ice cream flavors you can have, you've only selected those two. But all the possible ice cream flavors you can have, they're probably hundreds or thousands, right? That's what the codomain is. The codomain is where the numbers come from. What does it represent? So in our case, we're talking about numbers, and you'll find that in the methods course, we only often ever talk about R. R is all possible numbers you can work with. We don't work with complex numbers or imaginary numbers, but you can see that. Sometimes they say X maps onto all Z. So that means all the numbers that you're going to get, the x-axis represents every single number that's an integer. And I'm selecting a domain from that, okay? If that makes sense. So codomain is where you're selecting the numbers from. What kind of numbers are you working with? In our case, in methods, we always have R. So you will notice that always the notation is maps onto R, and then the domain is what they choose from all those numbers. They may say, I only want from 2 to, I don't know, infinity. And that's essentially what they're doing. So out of that list of all numbers you can have, they only wanted from 2 to all the positive values you can think of. Okay? So that's just to clarify the notation. So therefore, when you do the notation now, right, what they want to teach you is to translate all of this in terms of its domain, and then the notation is to write the function. So I'll do the first one just to get you rolling. The first one, A, okay, A tells me I want the set of all coordinates, okay? Set of all coordinates, so x, y coordinates, it could have been 3 dimensions, but this is a 2-dimensional plane where it's x and y axes. And the function will look like y equals to negative 3x plus 2. So set of coordinates that follow this pattern, and it's a linear pattern. So if I were to picture this, okay, the y-intercept is at 2, it's a negative graph, so it goes down, okay? Something like that. Clearly, the domain of this graph can be all real values, x element of all real values, and the y is also all real values. So when I write this now as a function notation, I can use f if I want, I could use g if I want, but I'm going to stick with f for now. So f, okay, this is my function, f is the domain R, so that's my domain, maps onto the list of numbers that I'm taking from. Well, we know that the x-axis can only be any number you want, so that's why it maps onto R, comma, okay, you always have to put it in comma, so you're saying that's what I'm doing. I am dealing with a graph where I have the domain of any number I want. I want to sketch them all, and the number that I'm drawing it onto, the x-axis, is going to be any number that I can draw, okay? And the function, well, that's where I use f of x instead of the y, is equal to negative 3x plus 2. That's what a function notation is. So it summarizes in this one sentence, it tells people straight away what the domain is, okay? And for those who later on in the future will know what the codomain is, and they can also then read the function. So what are you working with? So that means you can have different functions where you can use g, h, k, whatever it is, and you know it's different to this function. See, the problem in the junior years, you use y. The y value, you could have y equals 3x plus 1. You could have y is equal to 2x minus 1 and y equals to x. If I said, I'll use the y function, you're like, which one? Which one do I use? But if I labeled them, if I called this f, I called this g, and I called this h, then I could say, use the f function. Then you know it's this one. If I said h function, you know it's that one. That's why we get into the idea of using function notation so that we can tell the different types of function we're going to be using. That's why you have to learn the language, how to use mathematical language to describe what you want. Instead of writing this, takes too long. Okay, but let's do B together just so you get a vibe of how to do this. So B says that you want the set of coordinates where it follows the function. This is again a linear graph, and it tells you that it's only x greater than or equal to 0. So that means when I sketch this graph hypothetically, okay, the x-axis says it can only be greater than or equal to 0. And I can see that the y-intercept is at 5, and it's a negative graph, so it must be from 5 and it goes down, right? But notice that even though the graph is meant to continue, I can't sketch anything in the negative region of the x-axis because they wanted, when x is 0, that's all I'm going to keep. I'm going to start from x equals 0. So on the x-axis, I only sketch from here onwards. So you can see in this graph here, if I ask you what's the domain, well, you would say the domain is an element of 0 to infinity. True? Or you can write positive union 0. Up to you, whichever one you want to use. Okay? So if I were to use function notation this time, I would then say again, my function f has a domain of r plus, which means any positive number you can think of, including, so union, I list the number what I can include, which is 0, maps onto r, which is the x-axis represents any number that I can have, and I'm drawing only the positive values and including 0, comma, the function is negative 2x plus 5. Okay, so there's this sort of like streamlined way of writing my functions, no matter all these ones look different, don't they? Every single one of them look a bit different, but I can write them all in this template. That's what a function notation is. So we do C now, just to give you a better idea of what we're doing. C says y equals to 5x squared plus 6, and they tell me x can only work from negative 1 to 2. Hopefully, you don't have to sketch the graph anymore, and now you can sort of understand how to write it as a function notation. I would have just done f. The domain they already told us, it is clearly from negative 1 to 2, so you use interval notation. All right, so negative 1 to 2 maps onto r, because it's always going to be, that's where the numbers are drawn from. And then my function is 5x squared plus 6. So hopefully you're getting used to the idea of what we're doing here. You can have a go with D, but I'll do D just down here. You can pause the video if you like. But D says, I want you to sketch y equals 1 on x minus 2 squared. It's a truncus function, and x can be anything except 2. Okay, so if I were to write this as a function notation, I would say f colon, so my function f will be any number except, so backslash, not forward slash, backslash except 2. maps onto R, and the function is 1 on x minus 2 squared. There you go. That's what you do for example 10.